All right, welcome to class. I'm having great time with technology. Physical science. This is our textbook and our lab book. The lab book, for some reason, the bookstore has been renting people the lab book. The lab book has tear-out pages that you turn in, and so the rental model doesn't quite work. So if you have rented a textbook, let me know. Preferably you buy it, that way you can tear out the pages and turn them in, and it's easier. The textbook is written by Paul Hewitt. He's a reasonably famous physics educator. He's a cartoonist, so all of the drawings in there are his cartooning skills. I'm quickly going to go over syllabus material before I get started, but I will get started with actual talking about physics today. So first, there are some obvious things like where the class meets here, KC 133. The lab will also meet here Thursday afternoons at 2 p.m. So you'll come Monday, Wednesday, Friday at 10, and then Thursday afternoon at 2 p.m. The labs it's a 3-hour lab period. We usually will not use the entire 3 hours, but occasionally we will. So, I've had students who scheduled something for 4 p.m. So 60% of the time it was fine, but that 40% of the time they're still technically in class. And they're like, I got to go. I got something, so try not to double book yourself. My office hours are shown here. Notice Thursday morning is a good time. Monday afternoon and Wednesday afternoon are good times. I have lab Tuesday afternoon with another class. I often will be available to help you if you come during lab time on Tuesday afternoon as well. But just make sure those are my scheduled lab times or office hours. I should always be in my office and available to help students on a first come, first served basis during those times. Other times, if I'm in my office, feel free to come on in and ask me questions. Pretty much helping students is my highest priority. So, unless it's something crazy don't cheat, okay? That takes up more of my time than I wish. I'm chair of the Academic Integrity Committee, but generally I'll be available. The objectives of this course. How many people are education majors? You're not either? I know you are. Okay. So just Hosanna's not. I knew Hosanna. So for most of you, you're going to be going to teach a class, and this is your general science background. Now, you also have to take a chemistry class, right? No? Biology? Okay. Well, then you're going to go and you're going to be teaching grade school students primarily. Everyone here, elementary ed? Grade school students about science. You're going to do your little science project. Look, we made a little volcano. we grow. Or, we boiled water in the microwave versus boiled water on the stove, and then we put it on plants and we saw which one grew better. You guys have heard that bogus experiment, right? So I want you to understand what science is about. Not just understanding, some physics concepts, some chemistry concepts, some geology concepts, some astronomy concepts, but to understand what science is about. So one of my biggest goals for this class is for you to understand the scientific method. So I have here listed, I have 5 things I'm looking for to identify the major areas of physical science. Physical science, by the way, is science that's not biology. Just in case you're wondering about what that term means. And then to understand and be able to apply the scientific method, that is my biggest concern for the students coming out of this class. And to that end, we're going to have the same fundamental question on the first exam and the final exam. I'm going to tell you exactly what that fundamental question is. Now, notice I said fundamental question. It's going to have to do with the scientific method, both being able to regurgitate what it is and then to be able to actually apply it to a situation. Science is built on that scientific method. If what you're doing is built on the scientific method, it's science. If it's not, it's not science. It's that simple. So that's why that's such an important thing to me. And then to be able to take scientific data and draw conclusions from it that are based on the data, to actually have a connection between your data and your conclusions. Obviously, you're going to have to solve some problems. Conceptual problems means you're going to have questions that ask you about a concept. You don't have to do a calculation for it. You have to understand how the concept works. And then you have conventional problems where you have math that's going to be required, which is why this class requires that you've already completed Math 111, because there is some math you're going to have to do for solving problems. And then finally, to understand how science benefits society. Oftentimes you hear people say inane things like, why do I have to learn algebra? I'll never use that in life. Just a real practical example of why learning a little math helps. My wife's grandmother died. And so we were talking to her broker, and the broker said, oh, I will sell this stock for, we'll charge a 2% fee, no problem. And my wife's like, yeah, let's do it. I was like, no, let's talk about this. We'll talk about it. So after we leave her, I explained to her that 2% of the dollar value was a really big fee. And if we transfer the money to another broker who charges you per transaction, we would save approximately $13,000. And, she's one of those people who says, I don't need to know math. And it would have cost us like $13,000 because she didn't pay attention to math. So I want you to understand likewise why scientific knowledge is beneficial to us so you don't make mistakes. We have a course description here. We're going to be studying things in the physical world. That when we say physical science, we mean the physical world. So that's stuff you can touch, feel, manipulate. And the topics involved are physics, chemistry, astronomy, meteorology, and geology. Those are the topics that we'll talk about in this course. So I'm sure no one has covered all of these extensively. And meteorology, thankfully for me, because I went to a class on meteorology so I could teach this. And then I looked at the textbook and it has 10 pages on meteorology. So my understanding of meteorology is sufficient for this class because I don't know that one very well. The other ones, I have taught all of them as standalones except for chemistry, and chemistry is very tightly aligned with physics. So that's why I'm the teacher here. Then there's just basic things, in class. I brought my cell phone, but I'm not going to use my cell phone in class, and I do have the ringer turned off. So please do the same. Don't use your cell phone in class, and make sure the ringer is off so it doesn't disrupt things. If you have to go to the bathroom, I understand. Students do need to go to the bathroom, but try not to be disruptive. Accommodations, that's always an important one. If you have a learning difference, you need to go to the TLC. They will then guide you through how to get accommodations. And basically, they tell me what to do and I do it. So that's all about the Teaching Learning Center. If you don't know where it is, it's over in the Woods Auditorium. There's their phone number. I told you I'm the chair of the Academic Integrity Committee. So it's really important to me. Don't do anything that's dishonest, right? What's dishonest? Dishonest would be things like, well, everyone knows, copying somebody else on a test. That's dishonest, right? But there's other things that students often don't think about, or they think, oh, that's just a little thing, it's not going to matter. So for instance, there's a website, Chegg. Chegg is straight up a cheating website. It's there so students can cheat. It's not appropriate to go to Chegg or to go to Quora or Yahoo Answers or anything like that and just ask your question or find somebody else who's asked your question, take that answer and put it into your homework. Right? That's not your work. That would be cheating. It's also not appropriate to have a solution manual for the textbook and use that. Right? Those are things that are considered dishonest. So, don't do those things. On tests, I will simply say, if you have your cell phone with you and I find out, you'll get a 0 on the test. Doesn't matter if it came out of your pocket. That's because it's really hard to monitor if it came out of your pocket or not. So in that one, just make sure on test time, and I will always remind you to leave your cell phones up here. Smartwatches, same thing. It's 10:09. Yeah. I need to turn that off too. I usually have it off, but I like to hear Mickey say the time. So smartwatches, also prohibited on exams. Just make sure we're good on that. Here's how your grade is going to be broken up. Not today, but every other lecture, you're going to have to write down a question that you think would be a good question for a quiz or a test. And all quizzes, and this year, I plan on trying to have a quiz probably every Monday. They're not announced, so it's not like you can say, oh, he didn't say, so we're not going to have a quiz. I'm going to try to have one every Monday, so you can probably at least kind of plan that way. If I don't have it on Monday, then I really plan on Wednesday. I want to have a quiz every week. And those quiz questions will be taken from the questions you guys write. So they're not questions I write, they're questions the students write. And so each class period, except for today, I have these forms I'll give you. You'll put down a multiple choice question. You don't have to have the right answers. It's kind of nice if you put down the answers. It makes it easier for us to put in the computer. But you're putting down a multiple choice question, and then I will take those and I will grade them based on if it's on topic, right? If it's something we talked about in class, not something that was in the textbook in this period, but something we talked about in class, then it's on topic. On how reasonable the question is, I call it the quality. If it's a question that's too hard and no one's going to get right, that's not a good question. Who wants to put a question on a test that no one gets right? It's not testing their knowledge, it's just making them feel bad. If it's too easy, somebody doesn't have to know anything. It's just like, which one is the number 3? 1, 2, 3, 4, 5. That's also a low quality question. If it's a question that is of reasonable difficulty, that probably 75% of the students will get it. If you're paying attention, you'll get it. That's the kind of question I'm looking for. So that's what the quality is going to be based on. And then there is, what's the last one? There's 3 things. I actually have it written here. Originality. The originality is the one that, with only 7 people, it's a little easier. Originality, if it's something that I find in the textbook, you get a 0 for originality. Right? It should be something that you came up with, not something that the textbook came up with. Otherwise, if it's not something that I find in the textbook, if somebody else has fundamentally the same question, you lose a point. If 2 people have fundamentally the same question, you lose 2 points. If you're the only one that has fundamentally that question, then you get full credit. So that's what the originality one is. So that will be 5% of your grade is writing a question every day. By the way, when I go through and grade them, I just put a little red hash on one corner of it if I'm going to use it. That is if I'm going to put it in the list of questions to go on quizzes and tests. Half of your test questions will also come from questions that you guys wrote from the potential test questions. So if you have that little red corner, I should make sure I remember this question I wrote because it might show up on a quiz or test. Yeah.
If there's a question on a quiz, will it probably also be on the test, or will it definitely not be?
Maybe, not definitely either way, right? Because I'll put them into a list of questions, then I randomly draw from that list of questions for the quiz, and I randomly draw from a much larger list of questions for the test. So it could be on both, could be on neither. Okay, so we talked about the quizzes, homework. There are, I think it's 11 homework assignments. If you look at the last page here, we have the schedule, and you can see what we're going to talk about for each class period. So today is prologue, chapter 0 if you want. The final exam does include the prologue. I just put 1 for the starting chapter because I don't know what to put for the prologue. Class on Wednesday will be chapter 1, sections 1 through 7. And then lab on Thursday, we'll be doing the Sonic Ranger from page 11 in this. The first homework assignment will be due on Wednesday the 16th. You can see that right there. And so you can see when each homework assignment is. Now, we will use Moodle heavily in this class. The Moodle course is not set up right now. I will work on that, hopefully have it set up by this evening, and I'll add you all to the class. For the homework, I prefer if you turn it in on Moodle. If you turn on Moodle, you will have until basically midnight, like 11:55 on Wednesday night, to upload it as a PDF document on Moodle. And it needs to be a single file, by the way. If you want to turn it on paper, then you have to turn it in by 5 p.m. at my office. So you've got, 6 hours, 55 minutes extra time to do it on Moodle. I am trying to encourage you to upload it digitally. If you turn it on paper, I'm going to scan it, and it'll still be processed the same way. So the homework will be turned in on Moodle. The labs, you will turn the lab in before you leave the lab room. So when you come to lab, hopefully you've looked at it, have an idea what you're doing. You'll go through and do the lab experiment. The lab experiment is generally fill in the blank, maybe fill out a table, do some calculations, answer some questions that are written for you, and then you leave the paper when you leave. So you don't have lab work to worry about throughout the week. It's only during that 3-hour block. Okay, continuing on with what makes up credit for the class. Homework is 10%, just like quizzes, 11 homework assignments. It's roughly 1 per week, except for when we have a test. And then laboratory is 25%. The lab is, at least in theory, 1/4 of the class time, and hence I give it 1/4 of the lab grade, or the class grade, excuse me. I did not schedule a lab for the final week of the semester, but there is one for this week, just to make sure people don't miss. And then 30% is based on your midterm exams and 20% on a cumulative final exam. That final exam is going to test over all of the material of the semester. And since you guys are education, just to make sure you understand, I have this heartfelt belief that students are going to learn something in a class. That is, when they finish the class, they're going to know more than they did when they started. That's why I do a cumulative exam, so you can make sure that they actually retain that material. They didn't just learn it for the test and immediately forget it, which is something easy to do in many classes. So that's why it's a cumulative exam. I want to make sure people understand there's a reason for it. Hosanna?
Are there laboratory exams?
There's not a laboratory exam.
Okay. It just said midterm exams, so I was thinking maybe there's a midterm exam for the lab.
No, there's actually, and once again, I have all this stuff expanded here. There's a midterm exam on physics, one on chemistry, and one on geology. Those are the 3 midterm exams. And yes, I use the term midterm to mean somewhere in the middle of the term, not at the middle. Some people think midterm should only be at the 50% point, just in case you are confused by my terminology, because some students get a little perturbed by that.
So are those 3 separate tests?
They're 3 separate tests, yes. And if you look at the schedule there, you can see when each one is. This reminds me, I will learn your name on Thursday. Right now, I know Hosanna, I know, and the rest of them, I can look here and figure out who you are. But I will learn your names by Thursday. Promise, unless you don't come to lab on Thursday. Do you have a question? No. Okay, there is a final exam, Monday, 10 a.m., April 29. Can you believe all of my exams will be done before May Day? It's crazy, isn't it? So, if you need to change the final exam, you need to make arrangements with the Vice President of Academic Affairs. It's actually kind of funny. I always put that in my syllabus because I don't want to deal with it. The Vice President of Academic Affairs is like, oh, can't you just talk to the teacher and work it out? But according to the college, that's what you need to do, is to make the arrangements with the Vice President of Academic, it's not affairs, administration. Something you should know, at Union College, we have no affairs. Hence, there's no academic affairs or student affairs or anything like that. It's a conscious decision so that we don't use that word. So you know. There are dropped assignments. Your lowest quiz score will be dropped. Your lowest homework score will be dropped. No labs will be dropped. No exams will be dropped. But just to make sure you know that. I think I've talked about everything except for attendance. Well, there's 2 things, attendance and lecture assistance. Attendance, of course, I expect you to come to class. There at least was a policy at one point that students were allowed one excused absence per day of the week the class meets. So since this class meets 3 days a week, you would be allowed 3 excused absences for things like, going on a recruiting trip for the school or going on a gymnastics tour or something like that. And so I decided based on that I will consider it perfect attendance if you have no more than 3 absences. And I consider any absence, the first 3, I just say those must be excused. You must have had a valid reason. And then since you're only allowed 3 excused absences after that, it's not excused, right? So you don't have to say, now it's always nice for somebody to say, I'm not going to be in class on Friday because I have a wedding I have to go to or something like that, just so I know and can be prepared. But the first 3 absences, I won't blink an eye, it'll just be one of your 3 excused. If you have no more than that, then you get a 2% bonus to your final grade. But tardies also count against that. So the way I do it is, if you come within the first 5 minutes of class, say everyone was here within 5 minutes before class, excellent. If you come within the first 5 minutes, you lose 1 point. If you're more than 5 minutes late, you lose 2 points. And if you're absent, you lose 3 points. Also, I've had people do this, so I always have to mention it. If you leave in the middle of class and are gone for like 20 minutes, I've had people leave, go to the cafeteria, get a meal, and then come back at the end of class. You would also lose the 2 points there for the extended absence during class. Or if you're sitting on your cell phone, you would lose the 2 points for being on your cell phone during class instead of paying attention. So that's my only, you worked hard credit for the class. Everything else is based on merit. That's based on, hey, did you try? So that's all extra credit there for the attendance. I do have a policy there that if you are gone for more than 2 weeks, then I start lowering your grade. If you're gone for more than 2 weeks, the school says you can just give them an F and not worry about it, but I don't want to do that either. Last thing is lecture assistance. For many lectures, I'm doing demonstrations. For instance, in my class immediately following yours, we're doing electricity. I'm going to use this Van de Graaff generator to shock the bejesus out of myself during class. For most classes, I'll have some kind of demonstration thing I'll be doing in class. And so if you talk to me before class and we arrange what you're going to do to help me in my presentation with the demonstration and explain how it works, then you get up to 1% additional extra credit. So there's a total of 3% extra credit available to the class. 2% for attendance, and then 1% for doing that assistance. You can only do it once and get credit. You can do it every lecture period, but you can only get credit once for it. So that's what makes up your grade. And down here at the bottom of the page, we have what percentages will make up your final letter grade. And I do round, so 92.5 counts as a 93. 92.49 does not count as a 93. Make sure we're clear on that. And so you can see what percentage will get you what letter grade. Any syllabus questions? No? Sweet. Then I'll actually start talking about, physical science and whatnot. So I have here a list of what's in chapter 1. We're actually going through prologue now. So that's really not my focus for today. My focus for today is starting about what is physical science. Whoa, crud. That's not what's supposed to happen. This button here is supposed to advance. Yeah. Okay. I will have to check what setting got changed, but I won't use my button to advance it. Yeah.
Sorry, I was just wondering if you're going to post your PowerPoint online.
Yes, and also the lectures. I will be uploading the lectures to YouTube so you can listen to them and see whatever was on the screen as well. Okay, so not using this button for this lecture. Defining what science is. Remember I said that is my biggest goal in this class is to make sure you understand science and the scientific method. So science is knowledge that is gained by a certain method, by following the scientific method. And so the steps of the scientific method. This is steps that come from the textbook. On the next slide, I'm going to give you the steps that I want you to actually memorize. They're slightly different. You can pull out any textbook and you're going to find a slightly different variation of what the scientific method is. They all have the same fundamental things. And so I have my, what I consider simplified, it only has 4 steps for the scientific method. So first I'm going to go through here what the textbook has and then what I want you to learn. So first is observation. Science is very much about curiosity. If you're not curious about what's going on out there, then science is not something you're going to be interested in. Because scientists have to start that curiosity. They want to know why things work. So you start by observing something around you that's interesting and recognizing, wait, there's something interesting about this. It's not, simple. Then second is, it says there, question, hypothesize. A hypothesis is an educated guess. It's not just throwing a dart randomly. But you also don't know what the answer is. You don't know if you're right or not. You're saying, based on my understanding, I think this makes sense. That's what a hypothesis is. So the hypothesis needs to be built on existing scientific information. And it needs to explain why the thing you observed happened. And finally, and very importantly, it needs to make predictions. It needs to say, well, then if I do this, this should happen. So you have to have those 3 things for it to be a scientific hypothesis. So you make this hypothesis, your guess as to what's going to happen. And then, okay, this is listed separate, whereas in mine it's not. You predict, okay, if I do this experiment, this is what's going to happen based on my hypothesis, not based on something I've seen. Right? You're not saying, well, based on my observation, if I do this, this is going to happen. You already have seen your observation. You're taking something you haven't observed and say, if I do this, then this should happen if my hypothesis is correct. Then you test it. So you go and you do experiments. And then, this one here I don't really like, draw a conclusion. Yeah, you draw a conclusion, but that conclusion is just, I was right or I was wrong. And if you're right, you don't know that you're right, you just know that you didn't prove yourself wrong this time. And so you really don't draw a final conclusion. You say, based on this experiment, I appear to be right. And then what do? You go back and you do another experiment. The scientific method never ends. There is no, we've gone through the scientific method and we're done now. I did my research in graduate school. That research gave us certain things we believe, but we continue to test it, and it can be proven wrong. I believe it is Einstein, who's famous for, it's either Einstein or Newton, one of the, quote, gods of physics, who said, there is no experiment that can prove me right. But it only takes one experiment to prove me wrong. That's the way science works. If you have an experiment and it agrees with your hypothesis, great, you have more confidence, but you didn't prove it right. Because there could be other experiments that would have contradicted it. But if you find an experiment that contradicts it, you know it's wrong. So this is the textbook's version. My version, the one that you will be asked to regurgitate, is a little bit shorter. Starts with observe something interesting, just like we talked about. Then it has create a hypothesis, and you need to have those 3 parts for the hypothesis. You need to have a hypothesis that explains why the observation occurred, that is based on scientific ideas, and that makes predictions that can be tested. And then step 3 is test a prediction of your hypothesis. And then step 4, based on the outcome, and so this is completely different than what we saw before. Based on the outcome, if your hypothesis passed your test, you go back and you test your hypothesis differently. So you either test a different prediction, or you find a different way to test the prediction that you had already tested. So you can see right now you have a loop. If you pass the test, you go back and test again. You never get out of the cycle. If it fails the test, then you go back to step 2 and you say, okay, I've now ruled out this hypothesis, so what's a new hypothesis that could still be correct? And so if your test proves that you're wrong, because you can prove yourself wrong, then you go back and you have more information, you modify your hypothesis. So this is the scientific method. Now, sometimes we have discussions or people will talk about science and it's science, it must be true. That is not correct. I'm a scientist. I believe a lot in this stuff. But just because it's scientific doesn't mean it's true. It means it's the best understanding we have following this method. And so just to give you a really practical example, back 120 years ago, physicists thought they understood the world. There were very famous physicists who went on record saying, we now understand everything. All that remains is to maybe find more details on the digits and constant. And then Albert Einstein turned the world on its head. In 1905, Albert Einstein wrote 3 papers that completely revolutionized physics. You might hear people talk about modern physics. Modern physics is our understanding of physics since Albert Einstein wrote those papers. And what people had taken as truth, that they were sure that they tested over and over and over, turned out to be false. And so now we have a completely different understanding of certain things in physics. So what was scientific knowledge that everybody knew to be true was the truth. The same could occur today. Just an example of something that I think we could have a change like that in is our understanding of light. We say light behaves as a wave, like an ocean wave, but light also behaves as a particle, like a BB. And in any experiment, your experiment will either be explained with one or the other. To me, that sounds like that's a real big misunderstanding. We should have one cohesive theory that would explain both things, not 2 separate theories you just have to pick and choose. So I expect at some point, and that point maybe after we get to heaven, that we will learn that light is something different than we understand it to be today. So this is what you will have for a question on your first test and on the final exam. And so on the exams, both exams, you'll first be asked to just list the 4 steps. So you will write down, you'll have 1, you'll put observe something interesting. 2, create a hypothesis that, and you'll put the 3 little bullets, explain why the observation occurred, is based on scientific ideas, and makes testable predictions. Then 3, you'll have make a test of the hypothesis, and 4, you'll have if my test is confirmed, I'll go back and test differently or test a different prediction. If my test is disproves a hypothesis, I'll go back and change the hypothesis. That's the first half of the question. That you can have perfectly memorized. The second half, right, I tell you right now, because it's super important to me that you understand this. The second half, I will give you an example. I will say, I won't say observation, I'll give you something like this. Something like, you observe that when you eat ice cream at the dairy, it doesn't taste all that good. But when you go to Cold Stone Creamery and you eat ice cream, it tastes wonderful. The end. And then I'll say, use that in the scientific method. So you have to take that and you have to start with, okay, 1. 1 was observe something interesting. So what would your observation be? Okay, she said what I said. She was starting to put it in her own words. Either way is fine. You should. It's not like I'm trying to trick you. I just want you to recognize, yes, that's your observation. That's the first step. So don't just write down what you wrote above. I recommend writing a summary because I'm probably going to be verbose and you've got that kind of time when you're taking the test. Then step 2, hypothesis. Hypothesis that explains why is based on scientific ideas and makes a prediction. So first of all, I have to think about what do I know that would relate taste with environment. So what do you know that relates taste with environment?
Like, how can it work? Like advertisement, like Cold Stone is really like in the media kind of thing, where it's like this is the best ice cream. So when you go and taste it, good.
Okay, a preconceived notion. So you could that's different than where I go with this, but that's perfectly valid. you have a preconceived notion, and you can experience something because you expected it. I could give you many examples of that from my own life. You expect something's going to be better. So have you guys seen the things that they've done? Like they go to upscale restaurants and they sell people this wonderful water that's only $10 a cup that comes from the purest of Alpine Springs. And people buy it because they're pretentious. And they say, "Oh, this is wonderful." And then they show in the back they're just taking a hose and filling the cups with hose water. The water's not special at all, but because they expected it, they say it's better. So that would be a perfectly acceptable hypothesis. That's the scientific background. Because they have seen advertising that says the Cold Stone Creamery ice cream is going to taste better, they believe it tastes better. So that explains why it occurred. It's based on a scientific idea. We have experiments, previous work that's done to show that that works. And then, what predictions does this make? Okay, test it. So we could, instead of doing Cold Stone Creamery and a dairy, we could, say, okay, we're going to give you 2 ice creams. Here is the ice cream that costs us $10 per serving. This is the one that costs us 10 cents per serving. Tell us how they compare. Right? That would be a way of testing that hypothesis. Now, I've got to go with what I would have done because I feel like I'm a genius and I think it's really funny. My hypothesis is we also know that our sense of smell affects our sense of taste. And at the dairy, you have what, when I was in high school, we lovingly called the dairy air. What words? The smell of feces is in the air, right? And so my hypothesis is that smell of feces makes you say, "Ooh, this ice cream not quite so good." Whereas the Cold Stone Creamery, it smells wonderful, cookies and whatever. And so that enhances your sense of taste. So to test mine, then I come up with, okay, so we're going to have a testing room, and we're going to have some heaters. And we're going to put apple pies on the heaters. And then we're going to have people come in and eat ice cream and rate, how good is this ice cream from 1 to 10. And then we'll clear it out, and we'll replace the apple pies with cow pies. And we'll have people come in again, and we'll give them ice cream and have them eat it and rate it. Right? So that's definitely a test that's going to be seen. Is it the smell that's making it different? There's other things you could have gone with besides what Hosanna came up with. You could say it has something to do with the lighting or the sounds. There's lots of things you could have used. With my example, if they say it tastes better when they have the cow pies, then it's confirmed. Didn't prove it right, but I would come back and say, well, let's see how we can test it differently. If it turns out that it's the same in either environment, or God forbid, they thought it tasted better with the cow pies steaming, then I would disprove my hypothesis. And I would go to something like Hosanna's. So you would have to do that second part. That's just going to be based on the observation. You don't know what the observation is going to be beforehand. So you'll have to be thinking and applying these steps. Is that clear? The worst thing to happen is people come and say, "I had no idea I was going to have to do that. I thought I just had to memorize those steps and I'd be done." Right? Because that's happened. Now, that problem will be worth 8 points on the exam, and the exam will be worth something under 60. So that's more than 10% of your first exam's grade is that one question. So don't say, that's not important. It's super important to me. Okay, now some terms that especially we as creationists, I am a creationist, I believe that God created this universe, and I believe he created life on this earth, as described in Genesis. A lot of creationists will take some of these words and abuse them. So I want to make sure we know what they are. So first of all, a fact. Yeah, that's a fact. Is it a fact that the Oakland Raiders are the worst team in the NFL? Fortunately, it's not exactly a fact. We didn't have the worst record. I went to Arizona. And we beat them. So to have 2 lines of evidence saying we're not the worst. I'm a big Oakland. Okay, the Oakland Raiders don't exist anymore. I was a big Oakland Raider fan. I probably don't follow that. The city is suing them, and they have vowed they will never return to Oakland. But a fact is something that we can all observe and see, yeah, that's the case. So a fact would be that, and I'm sorry, I don't remember anyone but two people's names. So a fact is that Amber is sitting at her desk. We could all look at and agree that's a fact. Why is she sitting at her desk? Yeah, I don't have that exactly. A hypothesis is an educated guess. It's based on scientific ideas. Now remember, based on scientific ideas. Let's take something that some people would consider a hypothesis and other people would say no. A horoscope. Is a horoscope scientific? Let's talk about the basis of a horoscope. How does a horoscope work?
Or like in the time that you were born?
Based on when you're born. Taking the simplistic view, which is all I did because I don't believe in astrology. The simplistic view of the horoscope is saying that the position of the sun in the sky, the instant you were born, dictates what's going to happen in your life. Now there's scientific information involved here. The position of the sun in the sky is what we consider scientific information. So that's scientific. But then there is something that we as scientists say is definitely non-scientific. Drawing a connection between where the sun was when I was born and how my life is going to play out. We have no evidence to connect the two. And so scientists say that astrology is a pseudoscience. It pretends to be a science, but it's not, because there's no scientific link between where the sun was when I was born and how my life is going to play out. So that is not a scientific hypothesis, and hence we call that a pseudoscience. It's science in sheep's, wolf in sheep's clothing. Okay, then we have a theory. And this is where creationists started using words. A theory is basically a hypothesis that has been tested and tested until it's gotten to the point where no reasonable person is going to disagree. Now, I say no reasonable person. There are stronger and weaker hypotheses or theories. So let's take a strong theory. If I take this tennis ball and I let go, I have a theory about what's going to happen. I bet we all do, right? What's that theory? It'll fall. It's been tested literally billions of times, and it always works. It's just a theory. You know, I can't hold it here and say, it's a fact when I let go it's going to fall. It's a theory. After I let go it falls, I say, hey, it fell, that's a fact. But beforehand it was just a theory. Does that mean it's weak and something I should put faith in? Should I go ahead and say, well, I don't know, if he lets go this time it might not fall? No, that would be kind of silly. Just because it's a theory doesn't mean it's wrong or something we shouldn't believe. So you'll hear creationists who say that evolution is just a theory. Yeah, it's just a theory, but that doesn't mean that it's not something to be believed. You need stronger arguments than saying it's just a theory. Okay, now a law. The difference between a theory and a law is pretty thin. A law can also be broken. It's not immutable. It's just something that is very general and often can be summarized with an equation. So a law is basically a special case of a theory. It's not something special on its own. So notice, has not been contradicted. Doesn't say can't be contradicted. It hasn't been. Now, I've already touched on this a little. Our textbook author takes a completely different view of this than I do. But it's something that's important for us to understand as we venture into science. Science, as I've talked about, is based on following a certain method to gain knowledge about the natural world. Here is something that is not scientific. Doesn't mean not right, not scientific. And then a miracle occurred. Science says everything has to happen naturally. That is a basic foundational premise of science, that everything happens naturally. Well, a miracle is not natural. The definition of a miracle is something supernatural, something above nature. So anything that involves a supernatural being, i.e. God, is by definition not scientific. Now, there are some people who will say, and thus, there can be no, quote, creation science. Because creation is invoking that a miracle has occurred. And science is saying no miracles. Well, I have plenty of friends who are creation scientists, and they say, no, what we're studying in creation science is not studying the creative act, the miracle. We're studying if this miracle occurred, then is what we observe consistent with what would happen after. And so they're using scientific studies on scientific things, but just taking the premise that if there was a miracle that occurred to make this, then how would things play out? And so I fall on the side of creation science is science because you're not actually studying the miracles. You're studying outcomes that would happen naturally after the miracles. So in an origins class, we always start with this, and it's good to have it here. There are different ways of looking at science and religion. The one espoused, like I said, by our textbook authors is not the one I agree with. The one I believe is, and this is because, of course, I'm a Christian who believes that there is a God who created everything and is the ruler of everything. I believe that what the Bible tells me, properly understood, and what we see from nature, properly understood, they should agree. That's what I believe. Our textbook author, I've written a bunch of stuff here, I'm not going to read it, but he basically takes the view of what we call non-overlapping magisteria. It's called NOMA for short. And the idea of the non-overlapping magisteria, and I had another textbook where he states that somebody who believes that science and religion can conflict simply doesn't understand science or religion. That's his view. He believes that science is studying the real world. And religion is something to make you feel good. And so there's no overlap between those two. There can't be in his point of view. That's another view. I believe religion is a whole lot more than something that makes me feel good. And so I don't agree with him. So I have what he wrote here, and I have my own explanation. This is stuff for you to think about. You're not going to be tested on the relationship between science and religion. But as a student here at Union College, I certainly hope you leave Union College with a better understanding of how those two relate. Because discussions of science and religion, that's just a euphemism for creation versus evolution, are very strong in our church and are only going to get stronger. The topics for this class: physics, the study of the physical world. It's going to call physics the fundamental science. I'm a physicist. I totally am down with that. In my view, all of science is fundamentally physics. Physics, we're studying the very basics of things. We're going to study why I can walk, why I can see, those kinds of things. Then we have chemistry, which he has another name for it. It's not fundamental, but it's something, it's like ubiquitous, something that's everywhere. Chemistry, in my view as a physicist, is a subfield of physics. Originally, physics was studying all of physical science. But as they got more and more understanding, they realized that there's this area that really needs a lot of attention, and it's split off into chemistry. So there's a big overlap between chemistry and physics. Chemistry, you're studying the interactions between atoms. Then we get to earth science, which usually we call geology. Earth science is studying how physics applies to the earth. So it's a very fundamental physics thing, but we're studying just how it applies to the earth, so it gets its own name. And then finally here, astronomy. Astronomy is using physics to understand the cosmos, everything that's out there. And so we take everything we know about physics here on Earth and use it to try to understand what we see out there. Biology here I have in bluish color, because biology is not part of this class. Biology is definitely a science. Biology is studying the very complex life things. And that's something I am ignorant of. If we had biology in this class, I would have to have somebody else teach those parts. I wish I knew more. All right, we're done for today. I'll see you again on Wednesday.